The abalone dataset contained 4,177 records with each featuring 8 contribute relating to physical characteristics of abalone such as length, diameter, and hull weight. It contains one characteristical feature of sex as well. The range variable, which is target variable, is used to estimate the age of abalone as follows: age equal to rings plus 1.5 years. Since there were not any duplicate records or missing values, the analysis can commence immediately. In this step, we study the structure of data and notice some patterns. The sex feature was eventually split between male, female, and infant. The target variable rings has varied mostly between 7 and 12 with a slight screw. Some features like hull weight and shock weight display a small amount of screwings, along with high which few outlier correlation run prove the existence of interrelation of length, diameter, and shape weight, which is perfect for prediction but may result in some adversity such as multicollinearity by label encoding. We translate the sex feature into numerical values. The two key rules was applied to manage the rings outlier, which were depicted using box plots. This provides us an overview of information and put us in a good position for the modeling stage. To find which feature matter most for predicting rings, we use a random forest model. We split the data into 80% training and 20% test sets. Then we scale the feature using min-max scalar and standard scalar to make sure everything was on the same scale. The result shows that weight-relating feature was the most important for predicting rings. Chain weight was the top feature, followed by visceral weight, shock weight, and hull weight. Length and diameter were somewhat useful, but the sex feature didn't matter much. Random forest was great choice here because it can handle complex data and tell us which feature were the most useful. We tried different models to predict rings. First, we split the data into training, test set, and scale the feature. Linear regression and rate regression gave the best result with R-square of 0.53 and MSE of 5.1. These models explain how half of data variation and were easy to understand. Lasso regression didn't work as well with R-square of 0.14, meaning it didn't choose the right feature. KN and SVR did okay with R-square score of 0.50 and 0.41, but they were not as good as simpler model. Decision tree overfit the data with R-square of just 0.20. The multi-layer model didn't work as well, given flat prediction and negative R-square value. Overall, simple model like linear and rate regression work better. They were easy to use, understand, and provide good predictions for the dataset. These models were chosen for this dataset because of their low tuning requirement and how they treat the feature. Random forest was helpful in identifying significant feature because it's able to recognize more elaborate forms and relationships. These models were used because they perform very well with this type of dataset. Weight of abalone pair the most importance of age predictions. This will assist agricultural sectors where age of app learning is needed in predicting to harvest. For this type of data, linear ridge regression model perform right because they mathematically exist and are close to reality. In the future, we could try better removing outlier and getting rid of features so that the model become more precise. More sophisticated approach like random forest or neural network may deliver better performance if we further adjust them or have more data available. This demonstrates how proper selection of model should with data provided and straightforward results.